Hello and welcome to Mr. Jackson's physics class. Today we're going to do a static lab. What I'm going to do today is I'm going to be reading down through our static lab here and going down, and you can take observations and answer questions as we go along. If you want to pause the video to write in answers, you can do that. But we'll be working through the first 2 pages of the lab. That's the lab part. And then the last couple pages are the questions and answers and summary, okay? So there's more pages than just this. But I'm going to read through, and I'll be doing the conducting of the experiment with static electricity, okay? So number 1 says to put together an electroscope. So I have it already put together here. I have my conductive rod, which is then attached inside to 2 really very tiny thin pieces of aluminum foil, and you can see them in there. And what that does is that allows those foil leaves to move because they're so light. So I'm going to turn them just a little bit to the left or right like this, just so that you can see them. If I put them straight on, of course, they seem to disappear, so I'm going to turn them just a little bit so you can either see them move outward or inward, okay? So, question number 1, what is the purpose of an electroscope? The purpose of an electroscope is to detect charges. And how it detects charges, if you bring a charge near it, what happens is the leaves begin to move. So the leaves will begin to move. So you can see them move a little bit down there. You move that back a tad here a little bit. There we go. And so that is what they do. They begin to move if there's a charge. And as a charge develops, it pushes the leaves outward because they're light. They're repelling force because they'll always both get the same charge, and then they'll pull apart. And so the moving apart proves that there is actually a charge of some type on this balloon. Okay? It's not a very strong charge because they haven't charged it up very much. So there we go. Number 3, how can the electroscope detect different strength charges? Well, let you figure that out. Okay, here's a balloon, and you can see it's got a small charge. It is very hard not to charge a balloon. Just by rubbing your hand on it, you steal electrons or add electrons to it. If you rub it on the desk, I mean, there's all kinds of ways to give it a charge. So let's see how much charge it has right here, and then so we can bring it close. Then I just pull my hand away. So there's how much it moves. Okay? And let's see if just rubbing my hand on it. Do you notice that it actually even moves even more? So just by rubbing my hand on it, I've increased the charge. And so what happens when you increase the charge? Look at that. Okay, so how would you tell if the charge is increased? That's up to you, okay? I can even rub it on my shirt. And then, look at that. A really big change. Okay? There. So, then number 4 says, charge up a balloon with a negative charge by rubbing a piece of fur on it. So let me grab my fur, and that is... And so here you go, here's my fur, okay? And so I'm going to rub the fur on this balloon and really get some static charge on it so that you even get anywhere near it. You can see it has an effect, okay? So bring in the electroscope and describe what happens, okay? There you go. Look at that. I can hear it actually crackling here a little bit too. So, because it does jump over onto there. So it gets there, okay? So, there you go. What kind of method did I just use to charge the balloon? What method is that? Okay? Please note that method. There's the 3 methods we use. There it is right there. And we charged it up. Ooh. Then we go on to number 6. Explain what happens to electroscope by using the idea of electrons and protons. So if you look at that little picture at the top of the lab, if this is negative and I bring it towards this conducting rod, what do the electrons do? If there's electrons on here, what do the electrons do in here that causes that to separate? Okay, so you have to explain that, but there's a picture at the top of your lab that may help you put it into words, and if you want to do it, so you can do it that way, okay? So then number 7, it says use induction now to charge the electroscope the opposite of the balloon. So we're going to assume that this has gained electrons from our fur, okay? And so it's gained electrons, but it says we're going to call this charge we're going to put on here as positive. So I'm going to bring it near, and the leaves go out, but I'm going to come over here, and I'm going to touch it with my hand, and I'm going to allow it to pull off some stuff, or change it, and you notice it go back down, okay? Then I move it away, and so then what happens is, let me try it in a different way. I'm going to touch it here, bring the thing near it, and I want to touch this side. Pull my finger away. Whoop, it snapped, so I gotta get it. Takes a couple seconds to do it. Bring this near. Get the charge on here. It's not always easy. There we go. Whoop. Okay. Bring it near. Take my finger away. And there, it's charged. Well, I keep getting a opposite charge here. So let's do this again one more time. Oh, I can feel it. I can feel the electrons going down through the hairs, my arm hairs. There's so much static electricity. So bring it near like this. Get to expand out a little bit. Oop. And now it's out. Oop. I want to do this. So there we go. Oh, it wants to keep losing a charge today. I don't know why. Let me try this again one last time. We want to get a positive charge on here. To do that, I bring it near. This is induction, but I don't touch it. But I touch with a balloon, but I do touch it to ground it. So let's bring it like this. Take it away. And there, it should have a charge now. I don't know why it keeps losing it. So if it's opposite, okay. Okay, let me try this here. Okay, I got it all figured out. Here we go. I'm going to bring it near, so it just goes up just a little bit. So they separate just a little bit here. And as they begin to separate, what I want to do is I want to then touch it so that they fall back down, the leaves fall down. And pull my finger away, and then move the balloon. You see how they stay out. So now that has a positive charge. And to prove its opposite, as I bring the negative charge balloon near it, you see how they go back together? Because what happens is it's got a positive charge, but as I get near with the negatives don't want to be by each other, so there's still some negatives in there. They run down and balance the charges down here, causing them to swing together. So now I have a positive electroscope, and if I bring negative charges near it, it'll pull inward. Okay? If I bring a positive charge near it, it will go more outward. Okay? So let's see what's on here. So if I rub this, what should happen is I should be getting more negatives on the balloon. This should become positive. So let's see if it pushes those things inward. I gotta keep it away because it's such a sensitive device. Oh, that still is negative. And that's going to be negative. That's negative. Goes farther away. So there we go. Let's make sure it's positive. Okay, whoop, I did it again. Make the mistake here. Get to go up. Touch it. Move my finger away. Pull it back. It's now. It's not always so easy to get the charges you want. There we go. That's what we want right there. Pull it away, and it's charged. Okay? So negatives bring it back in. Positives will push it out farther. And so this should hopefully be See, it's more neutral, but you see it goes in just a hair. So anyway, let's go ahead and conduct our experiments, okay? So bring the fur you rub the balloon in the electroscope and see if there's any changes. So let's rub it over here. I'm going to move this balloon away as well. Rub it over here. And let's see if I can make this positive. So I'm going to bring it near. And it goes down a little bit, but also away. So it's not as well as I'd like to work, but this should be more positive than this. So let's rub it just more. And there. So that makes it go away. So I guess, whoop, I got too many charges around here. This thing is so ultra sensitive today because of the dry weather. So let's go ahead and just make sure it's charged again. Touch it there, pull my finger away, and there we go. Whoop. There, we are positively charged. Okay, so that's not doing it as well as I'd like. But let's go on into our experiment here. So this should have brought it closer together here, but we'll try some other stuff. So let's do that. Okay, so and let's go on to step number 9. Okay, 9 says touch the electroscope and remove all the charges and describe what happens. So now if they're spread out, if I touch it and I remove the electrons, what's that called? And I remove any charge, I should say. If I touch it, see how they went down? I removed all the charge. What's that process called when something is charged and you touch it? So here I'm going to bring this near it. My fingers away, and it's charged. Bring it near it again. Give it another charge. There, better charge. There you go. So opposite charge. So that must be positive because this is negative. Brings them close together, farther away. It gives them away. Now they're charged negatively. So there we go. So here we go. I have got some tape. Let's try to get some positive negative charge here. I have taped some tape to the table. And I've got A and B and C and D. And C and D are taped on top of each other. So let's see what happens. When we pull those pieces of tape off the table, they gather a charge. So let's go ahead and do that, and we can use the electroscope to tell us what's happening. Because remember, see how it goes together, we have a opposite charge. So we have a positive charge over here. So I pull my A tape up over here, get my little tab here, pull it up real slow. There's A. If I bring it near it, see how it spreads out farther? A little bit farther, they go apart, real small amount. That means so if they pull apart farther, then that must be the same charge as these. So these must be positive because they're spreading out farther. Because I remember I made it the opposite charge. So let's go ahead and pull this tape up. Again, B, let's bring that near it. Spreads it out farther. It's also got the same charge as A, which is positive. So if I bring these together, then they must want to repel from each other. So let's bring them together. So here we go. See how they bend away? They bend away from each other. See how they don't want to stick to each other. So those have the same charge. When I pulled them off the table, they must have had electrons taken away from the tape and left on the table. So they became positively charged, and so they make these leaves go out a little farther. So they go out farther. See that? So bring them close. So they have the same charge as the foil leaves, and we know through induction we left a positive charge on there. So there, when you pull the tape off the table, you can make the same charge, and it is oppositely charged. And see how they push away? They don't want to come near each other. So now, let's stick them back down for right now on the table. And then I have the C and D, so I'm going to pull these off the table. And so you can now answer question number 11. Okay, we just did number 11 for you, the A and B tape. So if you need to stop the tape, you can do that, the video, and answer those questions, attract or repel. So now we're going to go to question number 12. I'm going to pull off C and D. They are on top of each other. So you can see there's a tab there. So when I pull them up together, then I'll pull them apart. So let's pull them off the table. Okay, I pull them up. So now there's a single charge, but then I'm going to separate them. They were not pulled both off the table. I'm going to separate these two. So here we go. Pull them apart. like this. And now I have C. You can see C right here. And here's D. So as I bring them close together, watch what happens. See how they want to be together, so they have opposite charges. D was the one that was on the table. So let's see what D got for a charge. D, does it make it go farther apart? No, it brings it together. See how they go a little bit more together? And then C makes them go apart. See that? C makes them go apart. So C, if it makes it go farther apart, it must have the same charge as the leaves do. And if this one, let me try to help this out a little bit. Put these down here just for a second. And make sure it has a neck. Bring it out. Ground it. Don't touch it though. Ground it and pull my finger away. Whoop. Do it again one more time. So now they're sticking out. So they have a positive charge. They have opposite the balloon because I grounded it. So let's bring the C near it again. And C makes it go in. And sorry, that is D. D makes it go in. See how they go in just a really little bit? And C makes them go farther away. So that means D brings them in. D is the opposite charge, and C is the same charge. So they're opposite each other. So if I bring these two tapes by each other, we see that they pull in. See how they pull in towards each other? And they want to stick together. So there you go. That's how things get charged up by either rubbing against objects or being pulled off, okay? Or sometimes we do induction. So let's check the last few things. We're on part 13 here. And so you can answer 12 now that I showed you C and D's tape and what they have. Now let's look at number 13A. Let's comb our hair with a comb and see what it has. Remember, this was positive, so if I bring the negative near it, see how it goes down? But let's charge it up again because it slowly dissipates over time. So here we go. Rub my hair in the balloon, bring it near so it goes up. I take away that neutralize it, move my hand away, and then pull my fingers, and you see it goes out. So it's out right now, and if a negative charge comes near it, it goes in because it balances it. So that means that if this is negative, this is positive. So let's see what happens when we charge a comb. I'll comb my hair a little bit and bring it near. Look at it, goes in. It goes in. So what charge is on the comb if those two go together? What charge is that? It goes together. Oop, I just touched it. I got to make sure I don't. I discharge it by touching it by accident. So bring this near it. Bring them out. Move my finger away and then move this way so it's positively charged. Okay, bring it together. It brings it in. Brings it in. So this must be the opposite charge. Let's check flannel as it rubs on the balloon. So let's rub this balloon, and then we'll keep the balloon away, and let's see what the flannel does. Flannel makes them go out. Flannel makes it go out, so that must be the same charge as the balloon. I'm sorry, as the electroscope, not as the balloon. That comes together. See how that brings them together a little bit? But this one brings them farther apart. That one brings it together a little bit. There it goes. Far apart, together. And then this one brings them farther apart. So these are opposite charge. Now let's go back to the fur and let's see if these two have a charge. Let's make sure this is charged up. It slowly dissipates its charge. So let's charge it up, touch it, pull my finger away, and then pull it apart. See, they're separated. So now they have a positive charge on it. See how it brings them closer? Closer together, farther apart. There we go. So let's see if I can charge this up. Let's take my fur on a piece of copper pipe, and I rub the copper pipe, and I bring it near it, and it really has very little impact. and it is extremely difficult to get any kind of metal charged. And it shouldn't really get charged, and it's really not. And do you know why? Because I'm touching it. And so why is it difficult to really put a charge on a copper pipe? What is the problem? If I'm trying to charge this and I'm touching it, what's happening? That's for you to decide, okay? So there you go. There we are, using all kinds of objects, charging up balloons and charging up an electroscope and sensing charges. Go ahead and answer those questions. If you need to watch the video again, go ahead and do that, and you can answer the questions about what the charges were on each type of tape. I apologize if I sent the wrong letter, but I did repeat myself, so you should know what tape was which, okay? Thank you very much, and you have a great day. Blessings now.